Okay, so we've got a whole bunch of articles about Google's new quantum chip Willow.
Mm.
And a lot of people are asking about, well, they're asking about the multiverse.
Right.
Does it really open a portal to parallel universes?
It's a big question.
So that's our deep dive today. We'll lay out what we know and the different arguments and, well, you decide.
Yeah. It really brings together quantum computing and some pretty wild theoretical physics.
Yeah, and this chip, it's incredible. Solved a problem in under 5 minutes. A problem that would take a classical supercomputer 10 septillion years.
Wow.
Longer than the age of the universe. So how did
they do that?
How did Willow do it? Well, it uses these things called qubits, which can be in multiple states at the same time.
Right, superposition.
Yeah, exactly.
And that's where it gets really interesting. Hartmut Neven, he's the founder of Google's quantum AI team.
Mm-hmm.
He suggested that Willow's performance actually supports this idea of computation happening across multiple universes.
So he's saying Willow is doing its calculations in many universes, like all at the same time.
Yes. And that claim actually aligns with the many worlds interpretation of quantum mechanics, which was proposed by David Deutsch,
Okay.
a physicist.
Right. I've heard of him.
So Deutsch argues that every quantum event, like a qubit being in multiple states, splits the universe, creating a separate reality for each outcome.
So each one of these universes is running its own version of the computation, so it can find the answer way faster.
That's the idea. And he even uses Shor's algorithm as an example. Shor's algorithm is famous for its ability to break encryption. And Deutsch believes that its efficiency relies on this multiverse computation. Like, it couldn't be that fast if it were operating in just one universe.
Okay, so we've got Google's quantum AI lead saying Willow's success points to the multiverse. We have Deutsch's theory supporting it.
Right.
Seems pretty compelling.
Yep.
Is everyone on board?
Not quite. There's another side to this.
Okay, let's hear it.
So physicist Ethan Siegel, he argues that we can explain these quantum phenomena, like superposition, without even needing to think about the multiverse.
He believes that alternative interpretations of quantum mechanics, like the Copenhagen interpretation or the pilot wave theory, can explain Willow's speed within our own universe.
So Siegel's saying Willow is just super efficient at what it does in our own universe. No need to introduce parallel universes.
Exactly. And there's also the argument that the specific problem that Willow solved, which is called random circuit sampling, is mainly just a benchmark task for quantum computers.
Okay.
It doesn't necessarily reflect real-world applications yet.
So Willow's achievement is impressive.
Yeah.
But critics are saying it's not really hard proof of the multiverse. Plus, let's be honest, we don't have any tangible evidence that these parallel universes exist.
It's still theoretical.
Yeah.
And some argue that linking Willow to the multiverse is more philosophical than scientific.
At this point.
Right.
Okay, so the debate continues. But even if we just set aside this whole multiverse question for a second, Willow is still a pretty big step forward, isn't it? Oh, absolutely. Regardless of its connection to the multiverse, Willow's advancements in error reduction and its problem-solving capabilities are huge. It's a major leap towards making quantum computing commercially viable.
And that opens up a lot of possibilities. Multiverse or not.
A whole new world.
Yeah, exactly.
We could see revolutions in cryptography, medicine, material science, AI.
Which brings us to the next chapter of our deep dive. Let's move beyond this multiverse debate and explore what Willow's advancements could really mean for these real-world applications. And I think cryptography is a good place to start.
Yeah, sounds good. Cryptography is a good place to start. You mentioned revolutions. And when it comes to quantum computing, it's not an exaggeration. The ways that we encrypt things today, online transactions, all that, they're based on this difficulty of factoring large numbers for classical computers.
Yeah, so like finding all the prime numbers that multiply to make some giant number. Even the fastest supercomputers, it would take forever, right?
Exactly. That's what makes it secure. But a quantum computer, with the way it handles information, could potentially break these codes much faster.
So you're saying our online banking, our emails, everything, it could be vulnerable to quantum hacking.
It's a real concern, and that's why there's all this research into quantum-resistant cryptography, using those same principles of quantum mechanics to create new encryption methods that are secure, even against quantum attacks.
It's like a quantum arms race. Hackers developing these quantum tools to break codes, and the cryptographers developing quantum tools to build even stronger codes.
Exactly.
A constant game of cat and mouse with some pretty high stakes.
Yeah.
Okay, so cybersecurity is one area. What else can these quantum machines do? You mentioned material science.
Yeah, material science is another field
Yeah.
that's ripe for disruption. Quantum computers could simulate the behavior of molecules at a level of detail that classical computers just can't match.
So instead of doing experiments with materials in the lab, we could simulate those experiments on a quantum computer. You could design new materials, like super efficient solar panels, or lighter and stronger aircraft materials, or even like entirely new types of batteries.
Exactly. And it's not limited to just tweaking existing materials. We could discover entirely new ones with properties we haven't even thought of yet.
It's almost like alchemy, turning lead into gold,
Yeah.
but with quantum physics.
Good analogy.
So this level of precision in materials design, it could have ripple effects across so many industries.
Yeah, countless industries.
This is huge. What about healthcare? I remember reading something about personalized medicine and drug discovery.
Yeah, that's one of the most exciting areas. Quantum computers could really revolutionize drug development by simulating how different molecules interact with biological systems, so we could design drugs with much higher precision and efficacy.
So instead of spending all this time and money, years and billions of dollars, testing different compounds, we could use quantum simulations to find the most promising candidates much earlier.
Exactly. And it goes even further than that. Imagine using quantum computers to analyze an individual's genetic makeup, to predict their response to different treatments.
Wow.
So we're talking about truly personalized medicine, where treatments are tailored to each patient's needs.
That's amazing. It's
Yep.
like having a crystal ball for your health. You can predict problems and tailor treatments to prevent them.
Yeah, that's the promise. Of course, there's still a lot of challenges, but the potential benefits are huge.
Yeah, it's massive. So we've got cybersecurity, materials science, healthcare. It seems like quantum computing could touch every aspect of our lives.
That's what's so fascinating about this technology. It's not just about incremental improvements. It's about changing the way we approach problem solving.
Yeah, it's like opening up a whole new dimension of possibilities. Speaking of dimensions, makes you wonder if these quantum computers could also help us unlock some of the universe's deepest secrets, beyond these practical applications.
That's a great point, and a great segue to our final chapter. Beyond these revolutions in various fields, quantum computers could also help us delve into the mysteries of the cosmos, probe the fundamental laws of physics, and maybe even help us unravel the nature of reality itself.
Yeah, so we've talked about the potential of quantum computing to really transform these different fields, but it seems like its impact on fundamental science could be just as big.
Oh yeah, absolutely. Quantum computers, they could be these incredible tools for really probing the mysteries of the universe. Like imagine simulating the conditions of the early universe, like shortly after the Big Bang.
I can't even wrap my head around that. What could we learn from simulations like that?
Well, we could get a better understanding
Yeah.
of how the universe formed and how it evolved. Maybe even answer some questions about the nature of dark matter and dark energy, or shed some light on, the existence of other dimensions.
Well, so we could use these quantum computers to test some of the most mind-boggling theories in physics. I bet the astrophysicists and cosmologists are pretty excited about that.
Oh yeah, definitely. And quantum computers, they could also help us investigate the behavior of black holes.
Black holes are fascinating, but they're almost impossible to study directly. How could quantum computers help with that?
They could let us simulate the extreme conditions near a black hole's event horizon, where gravity is so strong that even light can't escape.
So we could basically simulate falling into a black hole without actually having to do it.
Exactly.
I'm good with that. So these quantum computers, they're not just tools for solving, practical problems. They're tools for expanding our understanding of the universe.
Yeah, a new lens through which to view reality.
And speaking of pushing the boundaries of what's possible, we can't ignore the AI in the quantum computer. We talked about how revolutionary quantum computing is. But what happens when you combine that with the power of AI?
That's right. The fusion of quantum computing and AI, or quantum AI. It's another frontier.
Yeah, and you said paradigm shifts earlier. It makes me think this isn't just AI getting faster. What kind of different things could QAI do that today's AI just can't?
Well, one of the most significant things would be QAI's ability to handle problems.
Yeah.
They're way too complex for even the most advanced AI systems today. Problems that involve just massive amounts of data and really complex relationships, like understanding and modeling these intricate biological systems, or simulating the behavior of financial markets with just incredible accuracy.
So it's not just doing the same things faster, it's doing things that were impossible before.
Yeah, that's right.
That opens up some pretty mind-blowing possibilities.
It really does. Like, think about drug discovery. QAI could analyze huge databases of molecular information and identify promising drug candidates so much faster and with such accuracy that it could lead to breakthroughs in treating diseases that are currently incurable.
So we could develop life-saving drugs much faster. And what about other fields like climate modeling or developing sustainable energy solutions?
Yeah, absolutely. QAI could help us understand and predict the effects of climate change so we could develop more effective strategies for mitigation and adaptation. And it could be really crucial in designing new materials for renewable energy, leading to a more sustainable future.
It's really incredible to think about how QAI could help address some of the most pressing challenges facing humanity.
It's a powerful technology.
It has the potential to be a really powerful force for good.
It does. But like with any powerful technology, it's important to think about the risks and the ethical implications as well.
That's a good point. We need to make sure that the development and use of QAI is guided by ethical principles and a commitment to using it for the benefit of all.
Yeah, these conversations are important, especially now, as we're on the verge of this new era.
So we've covered a lot of ground today. This mind-bending concept of the multiverse, the potential of quantum computing, and the even more extraordinary possibilities of QAI. It's clear we're living in a time of just incredible scientific advancement.
An exciting time
It is.
to witness these breakthroughs.
And the future isn't set in stone. It's shaped by the choices we make today.
So as you continue to explore this fascinating world of quantum computing, remember, you have a role to play in shaping the future. Stay curious, stay informed, and engage in the conversations. That will guide us towards a future where these technologies are used wisely and ethically.
Thank you for joining us on this deep dive into the world of quantum computing and the multiverse. We hope you found it as thought-provoking as we did. Until next time, keep exploring, keep questioning, and keep wondering.